Yes, Sasikal students, today we will discuss triangle law of vector addition. Well, before understanding the importance of this law, let us study the background why this law was made. So, students, let's understand like this. This is one body, this is some body. You can say this is a particle size body or a big body, whatever you think, right? Now, there is one person who is applying force on this body on this direction, right? Well, there is another person, students. He is applying force on this body in this direction. Now, the question is very simple question that in which direction the body will move, and second, what will be the magnitude with which the body will move. In other words, we can say what will be the magnitude of resultant. In other words, we can say if this force can be represented by a vector and this other force can be represented by b vector, then what will be the addition of these vectors? So in plain, you can say triangle law of vector addition helps us to add two vectors. Am I right? Very good. Now, addition of these two vectors would be given by r vector. This r vector is successfully representing addition of both the vectors, both in magnitude as well as in direction. Very good. Great. Now, in simple person's language, he might be tempted to think, or we can ask that simple person that if we are applying this force, let's say this is 5 Newton force, and we are applying this 6 Newton force, but totally in different direction, then in which direction the body will move? You see that, a rough guess, obviously a person cannot be so stupid, he will say the body will move in this direction. No, obviously not. We know this force is from left to right, so this will give left to right push to this body. But this force is, you can say, from bottom to up. So the body will have tendency to move like this also, like this also. So ultimately body will go somewhere like this. But this is just a guess. And guesswork do not give accurate measurement. So we have to think what will be this resultant correctly in magnitude as well as in direction. Students, this is the background of triangle of vector addition. Well said? Good. Now, students, what does triangle law of vector addition says? Or what is the definition of triangle of vector addition? In order to understand this, students, it's very important for you to understand order of vectors. Well, this thing is rarely explained by teachers. Students, look at these vectors. This is the head of the vector. This is tail of the vector. This is head of the vector. This is tail of the vector. You can say both the heads are coinciding. We can say the vectors are not in order. So how can these two vectors be in order? Well, this is really important. All right. So students, now, in order to understand order, we have to understand what is line of action. Well, line of action is basically an imaginary line along which a vector is acting. Am I right? It's an imaginary line. So what is that imaginary line? This imaginary line could be, extension of this vector. This is the imaginary line. This is the line of action of vector B. And students, this is the line of action of vector A. Beautiful. That is great. All right. We know these are the imaginary lines. Now, students, one thing I want to tell you, which you must understand perfectly, that if I take this vector B to some other position, see, this position, this position, this position, this position, this position, anywhere. Even if I take this vector in America or Japan, provided what? Two things remain constant. What? The magnitude of this vector plus direction, right? Direction. In case these two things are same, I can say the vector is successfully represented. Am I right? So means if someone say this is the vector, so this vector, is it represented by this vector? You will say no. Why? Let us say this is 5 centimeter in length, representing 5 Newton. Let's say this is also 5 centimeter in length, but you can see the direction has little bit changed. So this is not a representation of this vector. But you know, this vector, if I draw a vector just parallel to this, I'm not able to draw perfectly. Magnitude same, direction same. This vector and this vector are 100% same. Remember that. All right, students. I'm so happy teaching this. So students, once we have understood the concept of line of action, I bring this vector back here. All right. Now, students, we want to add these two. If you want to add two vectors, you know, in triangle law of vector addition, we must represent these two vectors by two sides of a triangle. All right, two sides of a triangle. But very important thing, students, taken in the same order. This thing some teachers miss sometimes, even some books miss this. So mean to say, what is the order? You know, order is simply, you know, students, now I tell you this vector you may take here, all right, and this vector you may take here. Now these two vectors are in same order. And what is the order of these two vectors? Students, very simple. The order of this vector is anti. Come on, students. Anyone?
Clockwise.
Beautiful. I'm so happy. Anti-clockwise. Now, can you arrange these two vectors in clockwise also? And whether they will give the same effect? This is a very interesting question. Yes, Kiran. If I change the order of this vector, will they give the same resultant or not? Interesting thing, the resultant will be same. Let's see how. This is very interesting. Okay, students, first we will find the, you know, what? We will find the resultant by this way. All right. So see, students, we have taken these two vectors in order, and you can also say in anti-clockwise order, the tip of one vector is coinciding with the you know, tail of other vector. And here, you know, means head and tip are not coinciding. Am I right? We can say this is the head of one vector and this is the tail of other vector. Then they are in the same order. All right. So students, what you do, these two vectors I have represented as two sides of a triangle taken in the same order. Let's say I'm going to form a triangle. Now close the triangle. The closing side of the triangle taken in the opposite order will give you the direction as well as magnitude of resultant. See that, students? Now, what is the closing side of triangle? Now, the closing side of triangle can be this also. Now, The question is whether the resultant will be in this direction or whether the resultant will be in this direction. See, students, if I take this blue vector as resultant, these three vectors are in the same order because see, head, tail, head, tail, head, tail. All these are in the same order. No, this is not triangle of vector addition. And also we know, students, just see, if you are applying force on a body in this direction as given by this vector, and this vector giving force in this direction, it is never possible that the body will move in downward direction as shown by this vector. Here the order is important. So students, what is, I'm sorry. So here, now the closing side of the triangle should be in the, any student, opposite
side.
order. This is the closing side of the triangle. We have taken this in the opposite order. This is truly representative of the resultant vector, which is equal to vector A plus vector B. All right, let's say this is vector, what was this vector A and B? Okay, fine. Now I will show this whether the resultant vector will be same in case I change the order. Let's see. So first I take this vector here, and then I'll see whether it is right or wrong. Fine. Now what I do, students, I change the order of the vectors. And now I have taken what, anti-clockwise, and now I will take what, clockwise order. You will see the resultant will not change. This may not be explained in much books. Let's see. So now any student can tell me how can I change the order of these two vectors from anti-clockwise to clockwise? Very simple. See, students, take this vector here. Interesting. It becomes, the order is, come on students, what is the order? Come on students.
Clockwise.
What is the order? The order is
Clockwise.
Clockwise. Now what will be resultant? When you join these, when you join the third side of the triangle taken in the opposite order, the order of these two vectors is clockwise. I am going to take the third vector in anti-clockwise order. In fact, the order for one vector cannot be defined. Order with two or three vectors together can be defined, right? Already we have two vectors, we can define order. So see students, this will be the resultant taken in the opposite order. Now you tell me, as I have explained, Kiranji, whether this vector and this vector are 100% same or not. See, they are parallel and their length is also same. If you don't believe, don't worry. I am going to take this vector and exactly coincide with this vector. Beautiful. That is same vector. I wish you all the best. Have a nice time, students. This is, what is triangle law of vector addition. So students, what I can say is that, triangle of vector addition successfully tells us how to add two forces. Okay, now students, you have already seen in front of you that the head of one vector will coincide with the tail of another vector. All right, so students, we can extend, we can give the statement of this also. If two vectors can be represented both in magnitude as well as direction by two sides. See, I need not write adjacent sides because two sides of a triangle will obviously be adjacent. Shabash. Direction by two sides of a triangle. Then the, I have to write here, two sides of a triangle taken in the, come on students, taken in the, any student can say if two vectors can be represented both in magnitude as well as direction by two sides of a triangle taken in the same order or opposite order, taken in the same
order.
Same order, then then the closing side. The closing side of the same triangle will represent resultant, obviously, of these two vectors, both in magnitude and direction, but what, students? Taken in the
Opposite order.
Opposite order. This is really an interesting law. So somebody says, let's say, do a little bit more, let's say that you have this vector, right? And then somebody says you have this vector, let's say, these two vectors, all right? So how will you do it? Somebody says, now where this point will move, in which direction this point will move, and with how much force this point will move. So what will you do? You would just maybe measure this in centimeter. Let's say this is in 6 centimeter. Let's say this is in 4 centimeter. And then what do you do, students? You have to represent these two vectors by the two sides of triangle, but they are not in the same order. So you can make them in the same order either by this or by this. You have seen the resultant will not get affected. Now, what is the closing side of triangle? Students, very simple. The closing side of triangle would be this. This will be the resultant. Very interesting thing, students. I'll change the order. Again, resultant will be same. Now, let's say I change the order of this like this. Then also the resultant would be, wait a second. I'm sorry. I've done something wrong. Yes, I'll take it here. Now the resultant is this. And you see that I'm getting perfect, kind of parallelogram. Means this side, like if I just join this, students, if you just see, if I join this is a perfect parallelogram. So parallelogram property, you know that what this vector and this vector are same in length. So if this is 6 centimeter, this is 4 centimeter. You simply measure the length of this vector. Let's say one was 6 Newton, other was 4 Newton. Let's say this is 9 centimeters, so this will be 9 Newton, and its direction is also specified. If you take horizontal here, and if you measure this angle, this will give you the angle measurement also. Thank you very much. If you like the video, share, and if you have not understood any part of video, write in comments. Thank you.